This meeting is being recorded.
In the last video, we looked at sample exercise 14 from chapter 17, and we dissolved our calcium fluoride salt in water. So we looked at part A, which would be with no common ions present. In the next two parts, we're going to take a look at what happens when we do have a common ion present. First, we'll look at a common cation, and then we'll take a look at a common anion. So in part B here, we have our calcium ion is our common ion. So let's see what happens to our solubility when we have that. So let's write our dissociation. So we have, it'll be for our salt. So we're going to have calcium 2 plus and our 2F negative will be present. So we know how to write our KSP. That's going to be the same as it was in the first part. Make sure to square that F negative because of that coefficient 2. And we have initially, we have 0.01 molar concentration of our calcium ions. We have none of our fluoride yet. So we're going to add S here, we're going to add 2S here, and we're going to get 0.010 plus S over here after the addition of our salt, and then we're going to get 2S over here. So let's take these values, plug them into our KSP expression here, and that'll be 2S squared. We're going to set this equal to that same constant as above, that 3.9 to the negative 11. So what happens here is this S we can actually disregard because that additional calcium won't impact our initial concentration of that common ion. So since that's very small, look at that solubility product constant, negative 11. So we know that we can just disregard that in our calculation. So we can rewrite this a little simpler as this form here, and that'll help us solve for our molar solubility. So this here would turn into 4s squared, and then when we multiply by 0.01, we're going to see that this ends up being 0.04. S squared is equal to that 3.9 to the negative 11. So we're going to divide both sides by 0.04, try to isolate that S variable. After we do that, we can take the square root now of each side. And when we do this, we're going to see that our S, our solubility now, is going to be equal to only 3.1 times 10 to the negative 5. So a smaller value than we saw above. Initially, we had 2.1 to the negative 4. So a smaller negative exponent means a larger solubility.